Hey YouTube, I'm back. It's been a long time working on the game, keeping my head down, but I'm here with another devlog. Hopefully I've got lots of exciting progress I can show you, and now I'm going to be back with more videos more often. So today I thought we would take a look at my main menu, my options screen, and some of the logging I've set up in my game, so it'll be ready for release soon. So enough chit chat, it's time to get down to action. Let's see what I got for you. Jumping right in. The game now has a menu, which is very exciting. So when you start the game, you're taken to this main menu. I wanted it to be something in the store. In the game code I set up, for every shelf you can go to in the game, I have in code just a position for it. And so in the game, when you go over to the shelf and you press X, the camera gets moved to that position and you're in this specific shelf. So I kind of hacked together a version of that. So there is a camera position at the slushies and pop machine here, which serves as our main menu. There's a couple different options here. You'll notice in the top right, I've added this button to go to the store page. Very exciting. As I'm recording this video, I'm currently working on the Steam store page. I'm hoping for the next one, I'll have that up and I can link it, and hopefully you guys can start checking that out. In terms of our options here in the main menu, there's 4 options. Obviously there's quit, which just shuts down the application. There's start, which will start the main game. Right now I'm focusing on finishing up a demo, so that start will play through the first couple levels of the game. And then there's this endless mode, which is currently grayed out. I'm not sure if I'm going to continue with this in the final release. I think I'd like to. I'd like to build it out into more of a mode. But for the demo right now, I just wanted to have something so after people play through the first couple levels, the endless mode will unlock, and they can just play some more combat. It's basically like a score mode. As you keep playing through, more enemies are spawning in faster, and you have to survive and see what your high score can be. To make the menu, I just took the pop machine I already had, I guess it's a slushy machine, and I just went ahead and duplicated the panels that had the different flavors, and then I had these labels I had already made for the pop and the slushies, so I just kind of modified it in a fun way, so instead of the brands of the soda, you get like start and endless and options. Something fun here, which I don't think I've talked too much about in the videos, is audio in the game. So you can hear in the background, there's like a little bit of white noise. Maybe I'll turn down the music so you can hear this. That's my fridge at home. I used a little recorder to get that kind of buzzing noise like you get with industrial machines. And then in the game, you can hear whenever you try and do things in your decline, so like this endless mode is not enabled. My girlfriend plays the bass, so I recorded her strumming on the bass to be kind of the decline noise, which is kind of fun. So that's mostly the main menu. The other thing I wanted to talk about was the 4th button you can press here, the options menu, which I put a bunch of work into. So you can access this from the main menu here, or you can get into this during gameplay. As you can see, I have 3 kind of tabs here, gameplay, video, and audio. This is probably a good time to also mention that all of the UI in the game is still up in the air. I don't know if I'll stick with this menu system, but for the time being, it was just trying to get something implemented. So starting looking at the audio, mostly straightforward. The volume controls here just allow you to control stuff like dialogue volume or music volume or the master volume. The output device is a bit more interesting actually. So I use SDL for the audio, so it's audio capabilities as well as a mixer, SDL mixer library. I wanted to start getting more into showing some of my code and trying to open up my engine a little more. So I wanted to kind of talk a little bit about this. This is a bit interesting. So with SDL, using it for audio, I had a bit of a hard time setting up this menu because when you first open up SDL's mixer setup, it'll default to whatever audio device Windows is currently using. But as far as I can tell with my current, maybe this has changed in updated versions of SDL. I'm trying to avoid updating any further because I don't want to break anything, but it won't tell you what the current output device is. So you can see in the menus here, I have it set to I think it's like system default or something. So anytime you go to change the audio device, you're going from your system's defaults to then starting to go through the different options in STL. This was a bit annoying. I also don't know how well this will handle stuff like if you were to unplug a device while using it. I'm not sure how gracefully my code will handle this, but thought that was kind of an interesting problem to hit. So taking a look at the video tab, this one's a bit more interesting. This got me excited implementing all of this. So some of the options here, you can enable or disable VSync. If you don't know, VSync locks your frame rate to 60 frames per second. Most computer monitors or TVs update at least 60 frames per second. So by doing that, you don't get any, it's called tearing, where you can see the last frame and the new frame and just kind of a horizontal line, which is a common problem in PC games. There's the FPS enable disable, so that just enables or disables at the top left corner being able to see the current frame rate. Underneath that, I have FXAA, so this is my anti-aliasing algorithm. So with computer graphics, it's a pretty common issue to have very pixelated images on screen where just you render these complex shapes and you end up with a lot of kind of harsh pixels. Sometimes people call them jaggies. So there's lots of different algorithms to handle this. I went with FXAA just because it was pretty quick to implement. I found a lot of resources online. I don't know if I'm finished with this, especially in different areas of the game. I do still see some rough anti-aliasing, especially with the brick section. And with the text and sprites in the game, I'm currently not applying the anti-aliasing algorithm. So I might circle back to this later, but I have some kind of cool, it's very satisfying. Implementing this felt really good because all of a sudden you could see such a big difference on screen. I have some nice before and afters here I'll show you. The last item you see here is the resolution. This was a lot of work I put into here because I'm now going to be releasing on PC on Steam. You really want to be able to provide that option to PC players to be able to adjust the resolution of the game. I put a lot of work into this so that the game can scale to different resolutions. You'll also notice there's clearly a blank spot in the menu here. That's if you want to enable or disable full screen or windowed. Working on this adjustable resolution, I had some trouble with the windowed mode, and the reason for that is when your game is running in full screen and you change the resolution, you have no problem outputting to that new resolution. Your monitor is now displaying at that new resolution, whereas if you run a windowed application and you adjust the resolution, the window stays the same resolution, if that makes sense. And now your application needs to scale to fit into that. So if you run your game at a lower resolution and the window is still at 1080p, you need to scale that image up. And if it's at a higher resolution, you need to scale it down. So I still have some work to do there. But you can see here, you can now control the resolution, you can adjust it. And if the game is meant to be run at 16:9, which is pretty common. If you select a resolution that isn't 16:9 aspect ratio, you can see black bars will be placed on the tops or the sides. And I can show you, I have some code here I'm using, which will let me select just the different options. I think my graphics card, I believe it's graphics card rather than monitor, supports in terms of output resolutions. And I just grab that list to decide what options to give the user. I should also note my recording program, OBS, it looks like it starts a recording at the current resolution. So right now, for me, I'm recording at 1080p, and it looks like changing my output resolution in full screen mode really messes with OBS because it's trying to record a 1080p image, and I'm changing the output resolution. So you can see OBS doesn't really like this. It doesn't handle it well, whereas on my screen it perfectly fits to the window rather than having black bars or images cut. The last tab here, the gameplay tab, you can see I have some dead zone controls. Ironically, I started implementing these menus and I was like, you know, it would probably be a good idea to be able to control the dead zones. And then shortly after that, my controller I've had for the better part of a decade started to, the joystick started to go on me. So even when I wasn't touching the joysticks, when I would run the game, my character would be spinning around because the sensor was just loose there. It was sending in signal even though I wasn't touching it. So at that point I was like, okay, I better put in some dead zones so I can still use this. So with this UI, I'm still subject to change. It's not really the best. It just gives you the option of you can test out the dead zones just to make sure when you aren't touching your controller, you're getting no input, and you can change each dead zone sensitivity. The last option here is the shopping mode option. I've been trying to kind of think ahead with the game of issues people might have once it starts distributing more widely. And I know probably different players are going to have different opinions on shopping in the store. I think some people will just want to kind of experience the story, go through the game at a decent clip, and they don't want to shop through the whole store looking for items every time you have to assemble a weapon. So this was my solution to hopefully preemptively address that. I have 3 modes here. So there's one mode where you just go through and it's up to you to find every item, to assemble weapons, or whatever's happening in the story, you have to find it in the store. There's another item or option where you can press a button on the controller and an arrow will appear which will point you where to go next. And then there's a third option which just defaults to showing that arrow. So once you pick up whatever item you needed next, the arrow will appear for the next one after that. The other part of these menu options are I need to save this data. So if you change your output resolution when you're running the game, the next time you start the game, you want it to run at that resolution, right? So I have Lua files that I save this to. Show you here, you can go through and just these values I will automatically update every time these menu options are changed. Alrighty, so this takes us to the last thing I wanted to talk about today, which was logging and log files. So if you don't know, in software, log files, those are just files that applications will write to when specific actions are performed. And the reason you want to have log files is if things break, with the log files, you should hopefully be able to go back and figure out what's causing things to break. So going back to that example before when I was talking about the audio output device, if I ship my game and someone's playing my game and all of a sudden they kick their headphones and the cable unplugs and the whole game crashes, the person playing the game might not know, like, oh, my headphones just unplugged. You need log files so that hopefully they can send those to me and I can tell them what's gone wrong and I can fix my code to be better handling that. I actually personally don't love log files. I guess I shouldn't say that, but when I worked in software, I worked at a couple companies where they logged out so much information, like down to like, without getting into nitty gritty, but it's almost like every time they added 2 numbers together, they wrote to a file, addition was performed at this time. And it got to the point where when things would break, it was almost impossible to find in the log file what was breaking things. So I had a bit of an aversion to doing log files for my game, but I was kind of forced into it. And the reason for that is soon I'm going to start shipping out demos and my game is going to start running on different computers. And I have no idea how it's going to fare. I'm really, really hoping it runs fine on different people's computers, different processors, different hard drives, different RAM, different graphics cards. But I'm also really, really worried that there's going to be problems, that people will go to run my game and it'll crash and they won't know why it's crashing and I won't know what their computer is like. So I needed to start using some log files to hopefully preemptively figure out what's going to break. So I set up logging for 3 different types of files. The first type of file will tell me about the user's computer, the hardware that is running it. The second one will log out as the game loads initially, just to see if things break at a certain step in loading. And the third one will log out when game state changes are happening. So starting with the hardware one, this was actually really interesting to do. It's a bit of a mess trying to collect hardware information about computers. All of my code here is really dependent on Windows. So if I ever go to port this to Linux or Mac, I think I'm gonna have to go through and set all this back up. So one of the tricky things with this logging is I can't do it all at once. And the reason why I say that is, for instance, with the hardware, I want to have information about what version of Windows is running. I want to know about the CPU. I want to know about RAM, the graphics card, and audio. And even going through this, I don't have it right now, but making this video, I'm realizing it would be good to know what controller they're using. But I don't want to do all of that immediately. And the reason for that is, if the game starts running okay, but setting up the graphics breaks things, I won't have access to that graphics information before the game breaks, before the game crashes. So I have it set up to go in kind of phases. So when the game first starts up, I log out the Windows information. Shortly after that, I log out the CPU and RAM information. After I initially start the graphics, I log out the GPU information. This code was really messy just ugly of the fact that NVIDIA GPUs seem to have different hardware information available than AMD GPUs, and if I have an Intel GPU I'm handling, which is just starting now, I'm gonna have problems with this code as well. So this was a bit messy. And then when I finally set up the audio, I print that out. So every time I reach these kind of new milestones in starting up the game, I update the hardware information file. I suspect this is going to be what I really end up looking at a lot when I have any issues, but like I said, I don't know where this is gonna break. If I knew how this was gonna break, I would fix it now. The next log file I have is the initialization log file, or just kind of the loading when you start the game log file. This I kind of used as an opportunity to get two birds with one stone. The game now has a loading screen, as you can see, which is very exciting. For a long time, it didn't. It was just a black screen. So now you can see what's happening, what stage it's at. And as it progresses through these stages, it's the same idea as the hardware. It updates a file. So I just made I think it's a static vector full of all of the stages in the game, and I display that on screen, and as it progresses through, it'll update on the screen and update in these files. I also have another file I've added, which is just timing information of how long each load is taking. That was more so trying to optimize the initial loading of the game, which has improved a lot. I might make another video on that, how much I've sped that up. But this is just kind of the initial setup. My last log file here is related to game state changes. So with my game, I preload almost everything in the game. This isn't like a open world game. It's not like Skyrim, where as you're progressing through the game, new assets are loaded and other assets are deallocated. I do almost all of my loading right when the game starts. So I'm hoping that there shouldn't be too many issues when the game is running. Like, I think the likelihood of a crash mid-gameplay is slim. So I don't have that much logging while the game is actually playing, but I've set this up just in case that does happen. Of every time you change the game state, it'll log out and it'll have the time it changed at. So if you go from the main menu to starting the game, it'll log that. If you go from the brick section in the game to shopping in the game, it'll log that. And that was kind of just a handle in case there are instances of things breaking while the game runs. Okay. That's another devlog down. Feels good to be back in the saddle doing this again, uploading videos. I've got way more coming soon, and hopefully the next video I'll be able to show you my Steam page and you guys can check it out. Thanks for coming along as we checked out the main menu, the options screen, and logging. Otherwise, thanks so much for watching, and I'll see you next time.